So please, if you notice, we'll be posting videos, like each class normally post video. So that video is for you to go and watch and then. When the video comes, they will not watch it. They are saving data. For your friend.
If you need pass question, please raise up your hand.
There's no time. Please check, read that question 1 on that circular motion dynamics. Please, the videos you post on YouTube is for you to watch and learn. Not if you see it, you will not. Then after you leave the person, start with the questions. Please, I can read question 1 on that circular dynamics. Check the PDF I sent you. Circular motion dynamics. First question, read it out. So please read out the first question. Question 1. If you are in the group, please read out question 1 for that circular motion dynamics. Good afternoon, students. Hope you are ready to learn. My friend. Hello, please, that camera should not fall down. I beg. Please, whichever class we are doing, we normally make a video. And as I was saying when I started, I said, once we post a video, please watch it. So that you don't see me in person, you still want to ask me questions on the first video we posted. Now I said, if you check the pictures, that's the
Yes, to ask for the first question.
There's a PDF we posted here. The first question that we can start. The one that was circular motion dynamics, the last PDF, physics PDF, the last PDF I posted to circular motion dynamics. Yes, the system science. The last PDF. Have you seen it? So because Rita is not here, that's to show you. If you see me complimenting or giving Rita gifts, you see. Because some of you are just in class because you want to be in class. If you say read question, don't wait for somebody. If you're waiting for somebody to read it, nobody will read it. I read out. It is of radius 10 centimeters. NCF is rotating about its axis. Is rotating about its axis. Its axis at an angular speed. At an angular speed of 20 rounds per second. Of 20 rounds. Find the linear speed. Find linear speed of I. A point on the ring. The I, a point on the ring. Yeah. I, a point on the ring, Yes. The middle point of the ring. Middle point of the radius. Of the radius. I. Centimeter force. I. Centimeter force. Then IV, the moment of inertia. Okay. Then IV. Yes. Moment of inertia. Okay, please, for this question, write somewhere, take M to the 200 grams. They did not give us mass. So, say take N, 200 grams. They did not give us mass now, they are asking us for centripetal force. Are you aware that before you can find centripetal force, you should have mass? So they're saying take N to be 200 grams. Okay, the moment of finish at the point,
At the point through I.
Okay, no, see, we'll not write that now. When I get to I, so that we can use our board well, you read that question, I. So it's staying through the center and through the edge, should we? Yes. So let's start with the I part. Alright, so please, the goal of my class is understanding. And I believe that if you pay attention, you must understand. Please, they said a piece of rate is 10 cm, but we know that you don't make it of 10 cm. You don't make it of cm. So 10 cm to meter is going to be 10 divided by 100. You should have seen it. Which is 0.1 meter. Let's check. They gave me gram, and I know that gram 2 kilograms is going to what? Divided by 1,000 grams, what we do? Yes. So that our what? 0.2. Alright. The angular speed given to me, W, equals to 20 grams per second, right? And then they are asking me to find their speed. And we know that from our class, those of you that do not start with us, this is the reason why you have to pay attention. Linear speed is actually given by V equals WR. Do you remember? Hope you remember. Yes. That's what linear speed is. V equals WR. I will derive it from our first class. We said that in kinematics we call it velocity, but in circular motion we call it W. Angular or omega. So when you now talk about circular motion, you always use now as a constant. So we have that. So now please notice that the question is telling us a point on the ring. So at a point on the ring, let's say I have a disc that is moving. And the time rate is this way. You need to pay attention. I notice some of you notice that you have to have variations. That is what makes things work well. If you are used to things happening in a particular way, it doesn't work well. So please, once in my class, what we are doing here is learning duals. So pay attention. Pay massive attention. Don't have it in mind that as we are doing this now, you should be losing focus to check your phone. The minute you check your phone and you go back, you call me back, you will have issues. So you need to pay attention. If this is the radius R, they are not telling me a point on the ring. Notice that if I'm talking about a point on the ring, it's simply that I'll make use of the whole radius. But if they tell me middle of the radius, notice that if I'm talking half of this radius, half of the radius. Are you seeing it? Yes. So which means that for the first question A, what I'll just do is to say 20 times the radius is what? The radius is 0.1, right? Alright, on for me. This is going to be what? 2 meters per second. Why for the II part? The II part, they say we should calculate the linear speed at the middle of the radius. So it simply means that I will simply say that this equals to WR. But this time around, middle of the radius simply means the radius divided by 2. So I will use V to be equals to W is 20, then 0.1 divided by 2. Watch for me, what they are. 1. So that is my answer, 1 meter per second. Please, if you've not been coming to tutorial class, unless you are very good at reading, and not just that you are good at reading, there is something called resilience. Unless you are good at, as you are reading, you are paying a deep attention to really get it. If not, most of the courses you have in university physics is deep. They are very deep. So if you feel you've not been coming for tutorial today is your first time, if you pay attention, you see that so much you will learn today. Yes. Alright, so that is for the V, middle of the radius. Now they're asking me for the centripetal force, and I know that centripetal force is simply a force that directs the body moving from the circular path to the center. So for anything to be rotating, for example, see what I mean? If I have an object, please pay attention. If an object is moving this way, and the force applied to it is moving this way, will it go through the circle? Will it go around? Let's say a body is moving this way, and the force pushing it is going this way as well. Will it form a circle? It's not possible. Rather, what will happen is that the velocity will increase. Are you aware? Yes. And if, for example, a body is moving this way, and the force acting on it is going this way, what will happen is that it will make this body at a point to stop moving. But the minute force is applied at an angle, the minute force is applied at an angle, what you get is rotation. Are you seeing it? Yes. That is why once you're talking about circular motion, we are talking about going at an angle. And remember that that's 360, shouldn't it? Yes. So what it means is that at 90 degrees, where force is applied here, if this body wants to move, because of the force that is applied here, if it wants to move, it will go this way. And when it's coming this way, this force will go this way. And when the body is trying to come this way, the force will come this way, the body will come this way. So that is what you get by that rotation. So if that is said, if they now ask me what is centripetal force, he said that it is that force that is fixed or that directs a body through the circular path, towards the center of the circular path. And it's given by F equals mv squared over r. Please, if you are starting today, we derived all these formulas. We are not just giving the formula for giving sake, we derived it. So if today is your first time, all you just need to do is check the video I posted on circular motion, kinematics of circular motion. Watch that video. Take your time and watch the video. If you finish watching it, you see how we derive all the formulas of circular motion. In my class, before I teach, I don't just start solving questions. I make sure we get everything it's all about before attending to the class. Alright, so using that formula now, let's find the centripetal force. Hope you know that if we are not finding the centripetal force, which radius should we be using? Shall we see that we have two things now, shall we? Calm down. We have when there is a point, middle of the radius, right? And we have when we are using at the edge of that radius. So if we are finding the force as our centripetal force, which arrow are we going to use? The one at the edge, right? Yes. So it shows that you know it. Because see, notice that this arrow that we use here is not arrow, but half arrow. I see it? Yes. So we are using R. And the R is just 0.1, shall that's what we are using. So F will be equals to, our mass is 0.2. 10 times, our velocity is what? Is it 2?
Yes.
Are you sure?
Yes.
What did we get? Okay, yes, so the 2. Thank you. All over, then our R, 0.1. But they are points on what they are. Okay, it's supposed to be squared, okay? But square for what they are. What they are? If you point, what am I getting? What we get with calculator? You got 8. 8, right? So I'm getting 8. So that's my answer. Please, those of you just watching in, don't shake my camera. This is the only saving I have. Because the way students meet me with questions, especially when they ask me with physics, this is my only saving grace. Once they come, I've posted the link, go and check it. I will rest. Yes, so please, once we post the video, even if you are not watching it that time, copy it and save it. So that once that your question arrives, you go and check the video. Alright, now let's go to the IV part. I said moment of inertia. And you remember that I told you that moment of inertia or inertia is simply the orientation of mass. Or you say the tendency of the body to resist change. If, for example, I want to push somebody and that person is hard to push, it means that that person's inertia is high. I see it? Yes. So if somebody is moving and that person actually has greater mass, the mass of that person is too big. That means that when the person starts moving, the person will have a higher momentum than the person that is having less mass. I see. So the more something, the bigger the thing, the bigger the energy. Are you understanding it now? Yes. So if they ask me to find the moment of inertia, I know that we got inertia today. Remember, we got that inertia is mr squared. Do you still remember? Yes. But not for a circular disc. Don't worry, we are coming here. We need to get something first. We need to get the inertia of the disc before we start talking about how much of inertia through the center and through the edge. As I'm not saying the question, I know there are two things that can ask you. And the two things is what is the inertia through the center and what is the inertia through the edge. What it means is, for example, if I have this to be a body of mass, if this body is rotating, is it rotating through this side? Is it this side, for example, that is turning? The edge that is turning? Or is something applied to it and it's turning from the middle? I see it. Yes, that is what they are asking you. Anytime they ask you through the center or through the edge. Is it from this side that is turning? That is from this end, or is there at the middle and it's rotating? So once you know that, you need to know that the inertia simply talks about mass, body of mass that is rotating. And when that body of mass is rotating, you are not checking the rotation. How is the body? Is it through the center? Is it through the edge? Alright, so inertia is given by mr squared. But for a circular disc, that is not how it's given. So we need to derive the inertia of the circular disc through the center. Then we derive the inertia of the circular disc through the edge. Now when we get it, we can be able to answer. So we need to pay attention. Because this thing involves electro-engineering foundation. Or should I say further mass foundation. So if the further mass foundation is not as strong, it's pay attention. Now I can claim because I know the rules. Once I see find moment of inertia, even without doing this whole question, I know there are two things that I can ask. Highest two things, through the center or through the edge. And I will always find through the center first, then I will still tell you why. Because once I find through the center, I can use parallel axis theory to find through the edge. So what I will say is, remember that inertia is given by integral of r squared to m. This is the formula. This is the general formula. This is the general formula. So write this on here. Integral inertia is given by the integral of r squared the m. Please, that the m is not mass. It's simply change in mass. Anytime you see the x over the y, it means change in x with respect to y. So the m, that means differential mass, changing mass. Mass that is changing, not mass. Alright. Now the next thing is to say, the next thing we need to check is, if I know this to be changing mass, I need to ask myself, if for this, the disc that you know, it's supposed to be something, if I draw it by side, it should be something of this nature. By the side, but if I face it, if I make you face it, it should be something of this nature. Yes, circular disc. Now, when we are judging this, we actually use this way. We place it in such a way that it's this way. When we are deriving this. Now, if we want to check this now, what we are judging is simply going to be this particular disc has area and it has length. L. If you don't call it length, you call it height. So we normally use volume of a cylinder to judge this, which means that we know that the volume of a cylinder is what? Volume of a cylinder.
1 over 3.
Awesome, 2 by. It should be pi r squared h. Is it not true? It should. That's what it should be. So what we now change when we are doing this is to say it's not height we are dealing with. We are dealing with length because of inertia. We know that inertia is about length or radius. So we'll change this. Now what we are now checking is that area of a circle is given by pi r squared. Is it not true? Then the length. So there are 2 things we are changing when we are judging this. Area and the length. So we now say that if you look at the circle has no volume. Are you aware? Because it's 2-dimensional. That is why if they ask you volume of a circle, you just use pi r squared. They ask you area, you still use pi r squared. Then if they ask you circumference, you say 2 pi r. Is it not true? But once they give you this, anytime you differentiate the volume of all those structures that you know, be it circle, cylinders, polygons, whatever, anytime you differentiate the volume, what you always going to get is the area. Let's do it. You see, this pi r squared, if I carry the 2 here from here, should you know how to do differentiation? You see that I will have 2 pi r. Should we? 2 minus 1 is 1. And I can leave it. Because anything on this one is raised to power 1. Then I'll come and bring the L down. So notice that what I've done here, I've differentiated this and I get the area of the circle. No, sorry, the circumference of the circle. So what I will now say is okay, that means that the area of a cylinder is simply 2 pi r L. So I'll get 2 pi r L. So I've gotten this. Now that I have this, the next thing I need to check is what is density. Notice that the first thing I did is to get volume. And I differentiated volume. Why? Because I see that there is mass and the mass is carrying and it needs change of differentiation. Now I'll ask myself, what is density? Density is represented with speed, which means rho. And density is equal to mass over volume. Is it not true? Density is equal to mass over volume. Now, we are dealing with a DC. So we ask ourselves, what will be the volume here? The volume is supposed to be pi r squared, shall we? Let's write it. So I have m over pi r squared n. Or I say m over a n. What below is the same? Yeah. If I want to make m subject of the formula here, it's the same as saying m is equal to b times b. So it's equal to b times b or b, that's rho times pi r squared n. Or rho times a n. It's the same thing. So now that I've gotten mass, what I now need to do is changing mass. Changing mass is what I need to do. Because we don't make use of mass in inertia. Remember I said, when the mass is moving linearly, or when we are checking, when we are looking at it just moving linearly, we call it mass. Or you classify it as momentum, mass that is moving. But the minute you start talking about rotation, its distribution, its resistance to movement, what you're talking about is inertia. So that mass has to be changing mass. That's what we're using. So for that reason, this n, let me get to the n. So to get to the n, that simply means instead of volume, I'm going to be using changing volume. So what we say in this case is to get the changing mass, I will say if I have this rotating, watch. It's from here we are checking it the volume. That's what from here we are checking, not guess what. If this thing is rotating, notice that let's say it is rotating to this side, it will be moving this way. Is it not true? Like all these axes will be feeling the vibration. Then towards the end. That's what will be happening now. It is rotating to the center. Let's say you put it around, or you put something underneath, then you turn it. It will be rotating this way. But notice that the length you are seeing will be the same. So that is why when doing this, we say that the length is the same. The length remains the same. If I'm rotating this, if there is no how I will be rotating it, I start to see that the length is looking big. It's not possible. But if I'm rotating it, if I'm looking through that window that is turning, I will be confused. Like I will not be seeing those things I see when it's not moving. So that's why we say that the area is what it is. So we say that that what we are going to be having here, length is the same, length is constant, density is always constant, but what will be changing the area. So the A is what I'm going to use like B. So that means that what I will have here will simply be equals to change in B. Then using this now I have my L in the state. Then change in A. Change in A. And notice that when I change A, notice that when I change area gave me 2 by now. You know, when I change area, it gave me 2 by now. That's why we started with it. Area is my R square for this one I have here. When I differentiated it, I got 2 by now. That is the change we are talking about differentiating. So I will replace this A is the sign as A. For A, it is my R square, but for changing A, it is 2 by R. So 2 by R. Then, remember that I already have the L that is here. Remember, so don't need to do this again. Remember, A-L, and the second we have, this L is not changed. So A and L, supposed to be density change A and L. So it's changing. So if I know this, it's simply that what it is that for the changing mass, differentiating mass of the differentiating mass is going to be density length then 2 by R. That is what I will have. Now, if you look some textbook, they will come and put something the R here. They will come and put the R. What are the R they are putting is saying that they differentiated everything here with respect to R. Notice that when I did this thing, 2 here, there minus 1. All these things is the value of the power of R I'm using to do this. I see it. So sometimes you see the R. This thing makes sure there's something you are doing with this. But it's just to show that yes, we did this with respect to R. So let's not confuse you. But don't think that your foundation and other maths is not that strong. So what it means is that here, anywhere I see all these things I did here, is so that I can be able to get this value. So that anywhere I see the N, I place it to this equivalent. So I will now say the N now becomes DL 2 by R. And replace it. The D here means differentiating mass. You know that because we did English in secondary school, once we see every alphabet, we want it to be giving us something. But please, the M simply means differentiating mass or say changing mass, and that is what we've gotten here. Differentiating mass simply means go and check what is changing here. Is it the length? Is it the volume? Or is it the area? That's what I've done, and I've gotten it. So if I have this, then I'll now come and write this is for everything here. Then I write my R square out of it. Then integral. Then equals to my N. Alright, now that I know this, the next thing I need to check is for radius, I need to check the boundary. The minute I do this, I'm not integrated, but I need to know the boundary. Am I going from 0 to R or from R over 2, negative R over 2 to R over 2? Let's get something, please. Notice that notice that when I come into this person, it's looking like a circle. Yeah. And if I know that this is a circle, the radius from here to here will be the same. It will be the same radius that gives me that circle. It's the same all through. It's the same all through. So I'm simply going to be having from origin to the R, the length of that radius. So I'm simply going to come and say that I'm differentiating from 0 to R. Assuming is something like a sphere, because I noticed that a sphere does not give me perfect circle. That's where I can go to another case. But for this case where if you look at it, maybe you don't have a circle, the radius is going to be the same from the origin to the radius. So if I know that now I can integrate. So to integrate now we simply bring out all my constant there. I bring out E, bring out F, bring out 2 pi. Then I now bring out R. Notice this is R square, Shebi. Is it not true? R times R will give me what? R will give, right? So now R is equal to 10. Then moving from R 0 to R. Now remember that in integration, if I have this R times R, which means R is equal to 10. To integrate simply means add 1 to the power. Then divide by the new power. Is it not true? So if I add 1 to this power now, I have 4 divided by 4. You see that this is advanced further mass. But why we have to do this is so that you learn it. So that when we are going on solving all those things, we don't have to be doing it again. Alright, so you now have that this is going to be RS power 4 divided by 4 from origin to the radius. So I now have, if I did this, I now have, when I'm doing this from R to 4 and then R to 0, but you know that anything divided by 0 is 0. So what this thing means, what this thing now means is that I will now have, in the situation I have RS power 4 over 4 minus RS power 0 over. I say it. Sorry, RS power 4. We send 0 here. When we have R to be 0, then we have our 4, then we have our over 4. Yes. So that is what it means. When we have R to the R, to the rest of everything. Then when we have R to be 0, that is the value to be 0. And you see that if you do it, it will still be 0. So no need doing this. So we just have to do this way. Now what we are going to be doing at this point is to say, density is something, shall we? What did we get the density to be when we started? This is it now, B. B represents something, which is M over what? Pi R squared. L. Is it not true? Yeah. So let's replace. We have M over volume, which is pi R squared L. Then there's L here. So this is density. L 2 pi, then R raised to power 4 over 4. Oh yeah, pi, take care of pi. R squared, take care of R4, I'll have 2. Okay, then L, take care of L. Is it not good? Then 2, 1, 2, 2. Is it not good? So I have moment of inertia to be able to bring out all the benefits. Is there anything that can still cancel? So I bring out M, bring out R. This R is supposed to go out 2. All over 2, shall we? And this is the sentence saying 1 over 2 M/R squared. Alright, so this is the moment of inertia from a circular disc or a cylindrical rod through the center. This is how you go about it. So please, copy it then. We now use this thing. That means that for that question, when they told us to find moment of inertia through the center, we just carry this formula. Then use it to get it. But me, the way I teach, I won't like to give you the formula you don't know. Tomorrow you'll cram it. If you forget it inside the that one, that is it. So what you get, how you get it is simply, yes, how you get it is simply differentiating the area and using the density. That is just how you get it. Alright, so I can click. No. Copy. So please, this is for through the center. Whenever you are trying to get moments of inertia through the center, you make use of your differentiating mass. And making use of differentiating mass is simply finding out what is changing and the density. While to get at the edge, moment of inertia at the edge, you use what we call parallel axis theory. And parallel axis theory simply states that once you know the moment of inertia through the center, that to get the moment of inertia at the edge, that you should simply add the moment of inertia through the center and mr, or you say mh squared. Very simple. Am I too fast? But let me do it. That's this part. It's a tutorial that can present you academically. It's a tutorial to present with knowledge. That's the truth. And why we are going to be doing this class and allowing you people that have not paid so that by January, we know that some of you just started and you're asking yourself, they've gone far. You've not gone far because that's everybody has started from the beginning. So I have said, I have my through the center to be half mr squared. That is the inertia to be half mr squared. That is through the center. And remember, anytime you want to derive point of inertia through the center, this is what you do. Now, if you want to get through the edge, you use parallel axis theory. And this parallel axis theory says that if you want to get the moment of inertia at the edge or through the edge, that all you need to do is to first find out moment of inertia through the center. Now, when you find out moment of inertia through the center, that you should add a factor to it. And what is that factor? You add a factor which is moment of inertia. You know that moment of inertia is m r squared. Is it not true? Yes. So you just add m h squared, or you use m r squared, because this r talks about the distance. Why I'm not using r here? Because it can be for even a straight line motion. So let's use l. This l means distance between the center part, and the edge. So the edge, from the edge to the center. To get the distance from the edge to the center. Let's do it so you see what I mean. I know that moment of inertia of a disk through the center is simply half m r squared. So to get moment of inertia through the edge now, we simply, I'll come and do plus m. Now I'll ask myself, what will be the distance if I have this to be the disk? I have this to be the edge, the edge, the edge, the edge. If I have this to be the center, what will be the distance from the center to the edge? Is stay r, is it not? Yes. Is stay r, so I can put r, put 2 here. By the time you sum this all, whatever it gives you is moment of inertia through the edge. That is what we call the parallel axis theory. What it means is that if this is the line, and this one is also parallel to this. That's why we call it parallel axis theory. So now let's do it. So I have, okay, sorry. This is going to be the center. The LCM is what? Because this is the center over 2, shading over 1. So the LCM is 2. 2 here, I just have m r squared. Here, I just have 2m r squared. So that I will have 3m r squared. See now, up here, m r squared plus 2m r squared is 3m r squared. Right? Yes, then divided by this all over 2. So it simply means that the moment of inertia through the edge is the same as saying 3 over 2 m r squared. Very simple. Yes. So for a circular disc, the moment of inertia through the edge is given by the expression 3 over 2 m r squared. You use parallel axis theorem to find that. So please, we are recording it so that by the time we post, you just go and watch this thing over and over and over and over and over. There is something called resilience. And when you talk about resilience, it simply means you having your own initiative and then you are adding deep attention to whatever it is you are trying to learn. And that is why when you come out with your own output, whoever listens to it will say, wow, yes, this is so on it. I notice most of the time, if you check your textbook to derive this, unless you are not very good in further maths, check your textbook deriving this with my wrong math. But once you go pay attention to it, you see that it's not hard. Alright, I want to play. Just check your friends with check your friends with now let's try use this to solve the question. Since we know through the center, moment of inertia, the formula for moment of inertia through the center, and we know the formula for moment of inertia through the edge. Let's now solve the question. What's the mass here? In that question given to us, let's say we should find this. 0.2. Okay, so we now have I through the center. I through the center is ICL. So the equals mass is 0 and half m r squared. So we have half 0.1. The iron comes, the radius 0.1 square. Upon it, whatever you get, the moment of inertia, ICL. So what do you have?
0.001.
0.001. Like this? Alright. Now, are you aware that what is it called? Let's check the formula for moment of inertia. Notice that we have mass here, see that too? And we have R, which is a meter, which means that the formula will be what? Kilogram meter. Kilogram meter. Yes. Please, you know this is. If you solve, let's say you have test given to you, a quiz is a test, and you solve without your units. You don't know what you're saying. That's why I told you that unit is the standard for comparing or expressing physical quantities. If I come here and tell you 2,000, your mind will be like 2,000 watts. You might even think it's money. But the minute I say 2,000 kg, you know I'm talking about mass. If I say 2,000 Kelvin, you know I'm talking about 10%. So that is the advantage of putting this. So whoever is finding once the person is 0.001, roll it. Let's just say you're talking to yourself. So always put your limit. Alright, let's find through the edge. To find through the edge, all we have to do is to use the formula. So and through the edge is represented as IP. It's represented as IP. So we now say 3 over 2 mr squared, which is equal to 3 over 2, I take out everything, that is 0.2, then 0.1 all squared. Punch for me, what do you have? In fact, anything you know about the moment of inertia, the minute they start giving you different shapes, have it in mind that the actual formula of moment of inertia is dash mr squared. It can be anything. Like if I start talking about a sphere now, it will no longer be 1 over 2 or 3 over 2. It will now be like 2 over 5. Yes. So we'll still derive it. So different shapes have their own moment of inertia. So always leave it as dash mr squared because it can change depending on the shape. Alright. So what did you get? Here, what did you get? 0 points. Like this. Okay. So kilogram meter squared. So that is my moment of inertia through the edge or through the parallel axis. So that is how you get there. Alright, give me question what now? Question 2. Well, let's clean so that we can start. I can clean this side. We need to be fast. We are working with time today. But please, no matter how hard it is, I want you to know that if you are finding time at night to use your subscription, you have night class. Even some of you are even good with hacking sites. Some of you will go to websites that you stay through it. You will be browsing free of charge. Yes. For those of you that use Symbian codes where we're doing your secondary school days. So please, just find a way to be getting that at night. You use it to download all the YouTube videos, like once you finish class, you normally post it. Reason being that you have time to watch this thing over and over. When you now have question, we'll come sit you down and explain to you. But if you've not watched the video, now come and meet me to explain. I'll first ask you, have you watched the video? What did I say in this case? What did I say? Once you watch the video, I'll now explain. But if you've not watched it, I'll take that. You myself, you don't want to help yourself. You just want me to be part. Alright, give me question 2. Let's be fast. It's up to them questions. Question 2, read. A uniform circular disc. Yeah, it's like you solve this one. Let me just write it out first. A uniform of 200 grams and radius 4.0 centimeter. It's rotated about 1 of the diameter. About 1 of this diameter. The most basic class ever. See how one person is reading questions. Just relax. I'm not speed of them. We say that angular momentum is represented What's the symbol for angular momentum? L, right? Find angular momentum. Okay. About the axis of the measure, yes? Okay. Please, do this one for me. 5 minutes. 5 minutes. Make sure you're doing something. Make sure you're doing something. You know my goal. I believe that by the time you enter exam hall, if you follow our class from this day, like from today is your first time, and you've been coming, from today till the day you write your exam, you enter exam hall, you will not see question. Do you hear me? I'm not joking. Because the way we are doing it, it's not perfect. The way we are doing it is something that when you enter the exam, most of your next questions, first questions, those are the things you have to hear. When you enter them, you will not see questions. Because whenever they want to bring out the question, we tackle it. So take what we are doing serious. It happens when you are very serious in any semester, even in your secondary school. Notice that a time will come, you enter the exam hall. It's looking as if everything they are doing is under your feet. But the time that starts, you don't read. You always wait for class time to come. You enter school before you copy assignments. You will not succeed. So all those assignments, those things they do as work that you are doing, believe me, that's your exam you are taking. Then when you now enter exam hall, you look like nothing. So take what we are doing serious. You see that you're already writing the exam inside lecture hall. So who is true? What's our answer? Let's do it together because of our time. Can I clean? I can clean. It looks as if once this physics class, everybody just wants to copy notes. I've noticed it. Everybody wants to copy what is on the board. Am I that fast? That's everybody wants to copy. Please, I want your attention first before the copy. I will not fill in. We'll take it gradually this time. Alright, there's a little circular list of mass 200 grams. So, any physics question, in order not to confuse yourself, always bring out your tools first or your parameters. So, I will say M is equal to 200 grams. And I know that I don't make use of grams. So, I will use kg. So, I will say times 1 kilogram is equal to 1,000 grams. And normally put anyone who wants to cancel that to replace the cancel. So this cancel this cancel this cancel. So I'm left with 0.2. And the next thing is they're asking me for a secular list. Now I know that what they're asking me in that question is angular momentum. And angular momentum is given by moment of inertia times angular velocity. Do you remember when we did talk where we said that linear momentum or momentum is equals to B, that is equals to mass and velocity. Then we said that once the body is rotating, it has inertia, and this one is the equivalent of angular velocity. So that is why we said that angular momentum is equals to inertia and angular velocity. Have it in mind that what you call mass, once the body is rotating, it's no longer, you don't just call it mass. You now call it, classify it as inertia. Because that body of mass now is actually fighting something that is rotating. Like a cathode missioner. You see, so it's fighting something. So going through that rotation is now called inertia. So its resistance to movement, or you say what its mass distribution. Because we when you rotate it, there is mass distribution. So that means this is what we have. So which means that for us to find the angular momentum, we need to find inertia. And we need to find, okay, we are given angular velocity. So we need to find inertia. So finding inertia now, notice that this thing is a circular disk. Some persons will just say inertia will be mr squared, but it's not true, right? The inertia here will be what? Half mr squared. Yes, we don't need to derive it today because it's a circular disk. So we say let's find the inertia. So we say I equals half mr squared. Now what is our r? They said this is 4.0. Shall we? Centimeter. Okay. So let me do that now. So r equals to 4 over 100. You know how to do? 0.04 millimeter. Alright, stop. The diameter. What happens to it? Does it affect it? No, no. See, what's diameter? Who can help us? Just over 2. Radius over 2, shall we? Read the question. They said, this is 4.0. See, read the question. Read the question. They said, radius of 4.0, shall we? Listen now. They said, radius of 4.0, right? Let's draw a circle. If I have this to be my circle, and I have this to be my radius of 4.0, what it means is that this thing is actually rotating on this axis, and then it's making this axis as well. I see it. So it has no business with me. I'm using my radius this thing. I have no business with it. So 4.0, which is the same. I told you that radius will always be the same once you're talking about that circle. So I will just have I to be equals to what did we get when we did our math? 0.2. 0.2. Then my r is going to be 0.04 squared. You are point for me so that we have our inertia. What do you have? Yeah. What did you get?
0.0016.
0.0016. Like this? 6. Like this?
Yes.
Kilogram meter square. Kilogram meter square. Kilogram meter square. You just enter actually. One of these diameter. Now look at this and see. Listen. They said, okay, you are asking, please pay attention. They said a uniform circular disc. I noticed that as I'm teaching here, the attention on that side is disturbing my class. Like, they say, well, I like doing things. You might see me like respecting status quo, but when things are not going normal, I will react. Because I don't like what is happening there. And we made it that today is just for tutorials. We know that there is no lectures today. So if anybody has anything to share, I believe whoever it is supposed to find a venue, just like some courses will do. So please, nobody should enter this hall and disturb this hall. Please. Now, somebody asked me, we know that there is something called through the center, a body being rotated through the center. Is it not true? And the body being rotated through the air. So she's asking, how do we know it is 1/2 mr squared we are using? Now, if you look at this question, they said it's rotated about 1 of its diameter. Is it not true? So that thing actually calls us to correction. Hello? That thing actually calls us to correction because if it is at the diameter that this that particular disc is rotating, it simply means that it's rotating at the edge. Are you seeing it? Yes, we know that we know that if I have radius from here to here to radius, that by the time we talk about one side of this and one side of this, all together it gives me what? Is it not good? So if you are telling me about 1 of its diameter, simply means that indirectly telling me about 1, or should I say about the edge. So what we're actually going to use here, we when we did this, for example, this is 3 over 2, should we? So this factor is supposed to be 3 over 2. So please punch it again. Thank you very much. Thank you very much. So punch it again, what we have? Punch 3 over 2 times 0.2 times 0.04. You have question? Punch, what did you get? I can't hear you. 0.00 kilogram meter. Yes. Yes. So please, this is correct. It's not wrong. I know what you are checking. How come? Yes. That is what that thing is trying to point us to. About one end of this diameter. What it's trying to tell us is that it is actually rotating on one axis. So if you do this now, what it simply means is that once I've gotten my momentum, then I shall now carry this and put here for momentum. Angular momentum, I'll say, you know that this is set as 4.8 times 10 raised to the power minus 4. Yes. Yeah, so let me use that. So I'll say M is equal to 4.8 times 10 raised to the power minus 4. Now my W is what? 10. But watch for me. You know that if you do this now, what it simply means is that you just do minus 4 plus 1. So this will be the same as M is equal to 4.8 times 10 raised to the power minus 4. And angular momentum, what's the unit for angular momentum? You remember when we said that angular momentum is equal to linear momentum times R. When we started, why most of you are looking at me? Because it's your first time. Yes. By the time people that started class with us, I once told you that once you are saying angular something, for example, torque is simply force man in angular motion. Just say force times R, torque. Velocity, angular velocity is simply W for angular velocity times R. So it simply means that linear angular momentum is just linear momentum times R. R is always constant. So if that be the case, I know that linear momentum is kilogram meter per second. So if you put this R, which is in meter, it will simply be the same as saying kilogram meter square per second. So that is the unit for angular momentum. So we say kilogram meter square per second. Very simple. The unit is always important. The unit is always important. If you hear about one end, or about one of its, just know that they are trying to tell you rotating at an end. Thank you very much. Because it is always entering your head to rush and use that of the center. Because immediately you do this, you remember this. Thank you. You can ask. You want to see over 2. But please, first of all, you said that the diameter is 2 times R. So you see how to if the diameter is 2 times R, it simply means the wheel in R here. You see how to? That's what it means. R one side. Now they tell you about one end of this diameter. About one end. It simply means that if I have this way, it can be the one end. If I have it this way, it can be the one end. But it's one side. Now, if that be the case, if I have a center here, we say that whichever one that is going through the center is called ICL, half MR squared. Whichever one that is going at an end or at an axis is called the parallel or say the edge. That is the one we use that parallel axis to define. So the question is trying to tell us about one end of this, about one of this diameter. So it's trying to tell us that it's about one edge. That's why they're using this. It's not hard. It's not hard. Alright, please. Is that all? For that question? If they don't say about one end, what can they not say is rotating, just rotating, shaping? I'll just use the center now. I'm thinking that it's rotating through the center. I see it. That means if that be the case, I can even if I use this one, I'll still not be wrong. It's Because it simply means maybe I'm using through the edge, or you are using through the end. But whoever is giving you this question will always tell you if it's through the center or through an axis. They will always point it out. Yes, just like that first one. They will always point out the axis is happening. If the inertia is rotating, if the body is rotating through the center, or if it's rotating through the edge, they will always point it out. Alright, please give me the question 3 now. Okay, let me play this one. What we are doing here today will be strange to people that have not been coming to class. Me and you. Because this topic that you see is like there's a combination of physics and further mathematics, including your methods. That is what we say secular dynamics. We are progressing. Give me the next one. Number 3. A circle of 10 meter, yes. Next, little evolutions. Every 4 seconds, yes. What is it? A period, yes. Frequency. Okay, centripetal acceleration. Okay, this centripetal acceleration here.
Centripetal force.
Okay, centripetal force, that's here.
Speed.
Speed. Just speed.
Yes.
Wow, okay. Effort.
Tension force.
Tension force. Wagabond. Turn to your neighbor and say Wagabond. Have you heard of Wagabond before? It's only a number of people that know of that. Yes. People from Anambra. Alright. They are normally using it. They use it well. We have that student that one time, once you talk, that should be last video. Once you say anything, they will say, hey, we will Wagabond. So that's that one from this. So now let's try to look at the question. They said a 2-kg ball moves in a circle of radius. So let's try out everything we are doing. For those of you that are just coming, who will say, what you are doing today, you've gone far. The way some people think is, once they enter any class and people are chorusing what you are saying, they start to think in their mind, these people have gone far. Some people will start to feel, oh, Jimo, Monimo, they've started again. No. Anywhere we are, that particular question, focus your mind here and start that place. That is why we are making it that before January, no matter what we've done, we are starting from the beginning. So that people that are joining us there, we have it in mind that everybody starts from the same place. So please, if you are starting now, and this is your first time, as you are seeing the question, understand what is happening, learn that particular one. When you go check the page, just like that the page that's on YouTube. Watch the videos on kinematics of circular motion. So you get the questions we are going. Then as we progress January, we now try not to miss class. So that we start from the beginning of the year. And all these things you see, they are very easy. The only reason why you see now is because you are new to it. If you do it over and over, you see that it's something that is easy, follows just a particular pattern, the repeating system. So let's look at it. Notice my own pattern is first of all, always bring out my mass. M is equal to 2 kg. That's my first stage. I always bring out the things I'm doing. R is equal to 10 meters. Then they give me 20 revolutions per second. Automatically in my mind, I take that one as a quick answer. Because I know that frequency is number of revolutions per second. So that one is bonus answer. So I just say frequency equals to 20 reps all over 4 seconds. Now, please, I give my students a shortcut. Oh, yeah, boss. Cameraman, see, I gave my students a shortcut. I told them that angular velocity, the minute you want to convert revolution to bar, what you are getting there is angular velocity. Just watch something. I want to convert this revolution, 20 revolutions per second, to pi per second. That is radian per second. You know that angular velocity is given by radian per second, Shemi? Yeah. So the minute you want to convert this, you've gotten your W. Because W is the same as saying 2 pi f. So this is it. I'll say W now will be equals to 20 rad over 4 sec. I will put 1 revolution. 1 revolution is equals to 2 pi. Is it not true? Yes. I always put revolution in the place revolution will cancel revolution. Is it not true? The minute you try to convert from revolution to pi, you've gotten your angular velocity. Now, see what it means. This thing now becomes your f. This thing now becomes 1 over anything is active, so you get 2 pi f. I see it? Yes. And that is what angular velocity is. And this thing means the same as saying, please notice something. F is the same as 1 over t. Is it not true? So if I put 2 pi with 1 over 2, you see that this is the same as 2 pi over t. Is it not true? Another formula for angular velocity. And then remember that linear velocity is equal to WR. Is it not true? So if you come and put 2 pi over t with r, you now get 2 pi r over t. Are you seeing it? And remember that this 2 pi r is the same as saying distance or circumference of the circle. Okay, catch over there. So this is how they get that formula. You see that it follows a repeating pattern, which is not hard. It's repeating. So that means that my angular velocity here. Somebody said, sir, oh yeah, punch for me. Revolute, cancel revolute. Then 2 here, 1. 2 here, 2. Baby? 2 here, 1. 2 here, what? And W is equals to 10 pi. You see what you have? Yes. And notice that there's second here. You see that we did not cancel second, everything we did not cancel. All over S. And this is the same as saying 10 pi per S. And you know that this thing is the same as saying 10 times 22 over 7. Hope you know. Yes. So I can leave it at this. I can also leave it at this. Alright, so I've got my angular velocity. I've got my frequency. Now, to get period, remember that period is simply the opposite of frequency. You still remember? If we say 1 over f, or we say second over revolution, or time over revolution, is still period. But for all this period and whatever we are saying, when we start doing simple harmonic motion proper, you will still see that we will go into it deeply. Like I told you, we are not missing anything. Ask my students. In my class, there is no trying to maybe solve everything so that you prove that you're always correct. No. In my class, it's very interrogative. Anybody can even come up with any question and will still solve it. That is my class for you. So it is a class that if you make anything less than A, as far as you're paying attention, you owe yourself a lot, not even you. Yes. If you've noticed the pattern we used to teach here. So please, for the period, I will simply say period, and you say T is equals to 1 over F. Alright, please look for me. 20 over 4 is what? 5. So 5. And I can use this in the revolution per second. Or I can say hertz. So, which is better than say 1 over 5. But here for me, 1 over 5 is what? 0 points. 0.2. Are you sure? Yes. 0.2 and seconds. Is it not true? So notice that I've gotten period, I've gotten frequency, and what I've gotten here is angular velocity. Hope you know. Maybe you know. So if they ask me linear speed or they just call it speed, we'll find out. So now let's find our centripetal acceleration. We know that when I started this class with you, I told you that as our centripetal acceleration is given by W squared R. Is it not true? Please, what we are doing today is what we call kinematics of circular motion, or circular motion dynamics. Sorry. Dynamics of circular motion, or circular motion dynamics. We call it rotational dynamics. So if you missed our video on circular motion kinematics, go and check it online. That is where we derive all the formulas one at a time. We derive all the formulas to see us using. So for centripetal acceleration, we just say W squared R. And because we've not gotten V, I can go ahead with this. But whenever we find V, we can still check. Do you remember that V is equals to WR? Yes. But let's try to find V. Let's check if the answer will be the same. V will be equals to our W is what? 10 pi. Is it not true? 10 pi. What about our R? 10. I'm not seeing Maxwell. Yes, that my friend on glasses. He always come up with questions. So I noticed you don't ask me questions today. Okay, we're repeating what we know, Shelly. Okay, but see, do for me now. What you do for me is 10 times 22/7. 10 times 10. What's for me? Let's see what you have.
3142.
3142. 3142.
Yeah.
Okay, and it's a meter per second, Shelly?
Yes.
Okay, 3140 meters per second. But let's now use this same formula now. That means that we can now use that formula of acceleration, which is V squared over R. And now we get that you simply say W squared. W is equals to making W squared formula is equal to V over R from here. Making W squared formula is V over R. So if you now come and say W squared, you now be W squared, which is V squared over R. Yes, and then putting the R to it. This cancel, this one was just square, yes, square. We derive the square check the so that we don't start confusing people that do it. So we get that. So now let's see this one, see if we get the same answer. So let's say A, C, centripetal acceleration will be equal to
It's 314.2.
okay, 314.2. Thank you. So 314.2 all square, Jenny? Then all over our R is 10. But let's check if we have the same thing here. Let's be sure. So I will have here to be 10 times 22/7. Everything all square. 10 times 10. What for me? Is it the same thing? Yes. What did you get for this other one?
9,807.
This is
807.
872, does it have points?
Yes, 0.16.
0.16?
4.
4, okay, we can just say 0.16. And you know it's the meter per second square, hope you know. Yes, meter per second square. Let's do this one. Is it the same thing that you're getting? One, now you first of all do 22/7. Then you times it to 10. You now take the square. Then times it to 10 again. Is it giving you the same thing?
Yes.
Okay, which means we are correct. So this acceleration is 9872.16 meter per second square. Yes. So that is our answer. Please, if today is your first time, find a friend, copy notes from the person, go to YouTube, watch our videos. Every class we do, we record it. So check the video on kinematics of circular motion. Watch it from beginning to the end. Watch this one. Go to your textbook and check. You see that you will not see any question that anybody wants to use at all. I'm telling you the truth. And if you enter exam hall, you even think that they do not set questions. I'm telling you the truth. It's not matchmaking. I know what I'm telling you. Because we are not leaving room for anything. We are leaving room for nothing. Alright. I ask. You got me. Okay, go. You got up. What's that? Blessing. You are very bad guys.
Transfer the
You know there's a class. You now bring students to come and disturb my class.
your ego.
You have got our agreement too. Even your mom to that place for tutorial. The brother was here last year. But then there's a class. You go pay everyone. Okay, dog, but ask me. Dog. Okay, problem is. They said in the presence of God there is liberty, Sherry. And anointing breaks the so you will see somebody that wants to ask questions before you know it anointing will touch the person. The question will be answered. Ask. Okay, this one. But first of all, see what you do for me. Sherry said W squared. See that? I'm not our W to be 10 pi. Sherry? But do for me this way. 10 times 22 over 7. Do first of all 22 over 7. Times it with 10. Then whatever answer you have, you double it like you do square of it. Then when you do square of it, you times it by 10.
This one is giving 9,807. And this one is giving 9,807.
Okay, this is giving, do it well.
9,807.
Okay, see why it's like that. I think the reason is that here is like we approximated here. Chevy, it's like we approximated here. It's supposed to be the same answer. It's supposed to be the same answer. Alright, now what is remaining is our speed, Chevy. Is it not true? Now notice that the speed we have here is actually
Centripetal force.
Are you seeing it? Hope you know. This is our speed. Are you aware? Yes. This is our V. Because if you're expecting us to come and be doing theta over t, then you don't give us time. So the speed here is actually linear speed.
So we have not found centripetal force.
Point what?
0.28.
Where?
Then if you make it 28, after the same answer, 9,807.
Okay, this one is supposed to be 2 8. And you can actually do that on your own. You can actually do it on your own, but we just know that we are very correct. Alright, I have watched for me, for linear speed, we've gotten it. Now, the next thing you need to pay attention, this is where we enter dynamics proper. Remember that dynamics simply talks about motion with respect to the force causing it. So nothing that everything we'll be dealing with just centripetal force. Now we want to find tension force. Dynamics will cover even the force that is acting on it. So please, let's check the tension force now. If I have, for example, a ball with 2 kg ball, let's say this is a ball, and it moves in a circle of radius, then between, so let's say, please pay attention. You said?
Yes.
Okay, we're not going to centripetal force.
Yes.
Okay, so now we actually say centripetal force is equal to M minus our acceleration, shall we? So mv squared over r. But use the acceleration you have here. That is
75.
75. Then times it with the mass, what you have? That is 2. So whatever you get is your centripetal force. So I have watched it. What do you have? For centripetal force, what did you get when you watch this?
19,000.
8,770. So that's what this is.
No, Christian.
19,000.
19,740.
What happened is the acceleration.
Give me the final answer, right? Please, give me. Please, punch 2,000 with the acceleration. What do you have? I don't need this going back and forth. These are words that you can actually look at it well and see what is in there. Watch for me. 2 times this. What do you have?
19,000.
Point 19745.
0.5.
Okay, in Newton. Alright, so this is my centripetal force. Now please, they are asking us for tension force. It is not the same thing. Tension force and centripetal force, they are not the same thing. When they ask you tension force, it's simply talking about what is the total force acting on that body vertically and horizontally. What is the total force acting on that body vertically and horizontally? And we know that tension force is always peculiar to force on a rope. Yes. So we are making it now that if this ball is rotating around the circle and the essence of tension force, we are actually saying that maybe a rope is tied somewhere and it's running around. So what we will check is, are these vertical axes? What will be the force acting this way? And what will be the force acting this way? So please, have this in mind on the x-axis or on the horizontal part, the force that acts this way is plus centripetal force. Putting it towards the center. When at this point, when this ball is this way, when this ball is up here, it's not the force that is directing it downwards. So the tension force here, see here will be equals to mg. While this side, the force here will simply be mv squared over r. Which means that if I want to now find the tension force, I will simply do, this is x-axis, this is y-axis. I will simply do resolving of vectors. So that I will now have, remember it's a ball they are talking about, moving in a circle, a uniform circle, moving in a circle of radius. Now this is not going to be, this is the rotation I do. How is moving? That's why I do this side. So this is not going to be tension force will be equals to force on the x-axis, force on the y-axis. So square root of force on the y-axis plus force on the x-axis. Do you remember our Pythagoras now? When we have something of this nature, this way, we'll get r. Let's say this is b. Sorry, let's use fx here. Let's use fy. So by the time you do that, our normal r squared equals to fx squared plus fy squared. By the time you make this one solid of the formula, you see that it's okay. And in this case, our area is t, the tension force. So that's what the formula we are using here. So what this simply means is that when I get t to the equals to, our m is what? 2, right? And as acceleration due to gravity, I'm using it to be 10. If I use it all to the 9.8, it's what to do. So, which means that I will then get 20. So 20 squared plus, now our centripetal force we got 19,745. So I'll get 19,745.5 all squared. Now by the time you punch this for me, and do everything there, whatever answer you have is your tension force. Please, tension force is different from centripetal force. Note it. Whenever you are asked a body moving in a circular path, what is the tension force? What you need to be checking is, did they give you a particular path that tension force is acting? If they did not give you, the total tension force that is acting on the circular path is going to be the force on the vertical axis and the force on the horizontal axis. That is what you check. But if they give you a particular direction, that is where you now be checking. Let's say they tell you what is the tension when the body is at the top. You now be checking at the top, is it going against gravity or obeying gravity? If they say bottom, when the body is at the bottom, you now be checking when it's at the bottom, is it obeying gravity or going against gravity? They can tell you at the middle. You now be checking. At that point, once it's middle, is it tension force that will be acting there or centripetal force that will be directing it to the center? So in this case, they're asking us for tension force, they did not specify. So it is simply going to be force that is acting vertically and the one that is acting horizontally. Remember I told you that a circle does not have volume. The reason being that it has just 2 dimensions. Do you still remember? Very important. So the vertical and the horizontal. You're taking note of all these electronics I'm saying. So now watch this thing for me. What do you have?
The same 19,700.
So see, let's see. Square this, add it up. Take the square root. You get
19.
0.5, so notice that it didn't make much difference. Are you seeing it? It made no difference. So, but why you are doing this is to show them, like, to be sure. Because there are cases where you might finish this, you see that it might give you 0.6 to give you slight changes. So it's very important to know that. So, but when we don't start teaching you manual, you can just say you can use your centripetal force. Yes. But please, when you are doing this, there was a proper way to find the tension force. Alright. That means we'll finish question 3 now. You see that though? We are done with question 3. Question 1, question 4 now.
So in the remaining frequency.
Okay, I think we should find the question. Please, because of time, I want us to quickly go to the question that has, hello, Okay, we still have time. I started at 2. Okay, see here. Question 4. Let's go to question 4. After question 4, we will go to the question that has to do with banking. Banking of road and frictional force in that question. I want us to take all those questions that deals with force, banking of road.
The first question.
Please, hope you are still here. Are you still here? Please, if you are not here, go and eat something. But be here. Do you know one thing? One thing I notice is that every year students are becoming lazier. Yes. Because if you check it, these days, once you start teaching, students want you to just teach for like 30 minutes or 1 hour. Then use like for all the remaining minutes, maybe to converse and the rest. No, we are dealing with time. And physics is a very deep course. That is why you go for some external exam. In your those days you were in secondary school, when they are teaching you in your school, it looks as if you know everything is easy. Once you go for external exam, everything will be different. You will not be picking answers you know and the one you don't know. Because it's deep, a lot needs to be covered. We need to cover a lot. And if we don't do it, you will find that you will be in such a situation. So that is why we are trying to cover everything. So that when you enter that case, once you come across it, you go through it over and over. Because you do not look at my answer.
I saw online that this tension force is well done. Centrifugal force square, that's the square plus tangential acceleration, tangential force square.
Tangential force square.
That is 4 times. I saw 4 times. That's the formula for centrifugal force. Then that is mass times centrifugal acceleration. Then plus force times tangential acceleration, all square. I'm asking, is it correct?
Okay, please, notice that what we are dealing with is uniform circle. Is it not true? The question given to us, is it not a uniform circle? Hello? Is it not a uniform circle? Please, when we started class this year, that's the noise. I told you that anytime you are dealing with uniform circle, we have no business with tangential acceleration. When we started, I told you that tangential acceleration is that acceleration that is found when a body that is in circular motion is slowing down or speeding up. See what I said? So, assuming I'm to use that your formula, it will be when I'm dealing with a body that is slowing down or a body that is not in uniform circular motion. That's why I normally make mention of everything. I try to cut across everything. So please, once I am dealing with a uniform circular motion, I'm just considering force acting on it vertically and the one acting on it horizontally. I say this? Yes. So talk about tangential force when we are dealing with a non-uniform circle, or when we are talking about a body that is slowing down or that is speeding up. Once it's uniform, it means that the acceleration is being directed towards the center, and everything, the velocity is not changing. The velocity is steady. And we say that with constant velocity for circular motion, the body will have acceleration. Acceleration will not be zero, because acceleration in this case is talking about pointing it to the center, making sure that it hits circular parts. It hits the circular parts. Alright. Now, if we know this, read question 4. Question 4, does it have anything to do with force? I want to be dealing with questions that have to do with force now. Nothing like force there.
Centripetal acceleration.
Okay, centripetal acceleration only.
In G.
Okay, in G. That thing in G simply means once you get your centripetal acceleration, now you will say convert it to G. And you know that converting to G, for example, you get meter per second square, Shemi?
Yes.
You get meter per second square. Acceleration that you get for centripetal acceleration is always meter per second square, Shemi?
The answer was 20.
C times 1/9.8 or 10 meter per second square.
Just divide it by 10.
Yes, because we know that, see, this is the value of G now. Acceleration is together, Shemi? And acceleration is together is a meter per second square. So this will cancel this. So, when you divide with this, that is just your acceleration in G. So, please, let's move to a question that has to do with force. Check the one that has force to it. Because the second question dynamics is available. That has to be, let's solve it. Which one has force here? Read now. Question. Read. Read now. You're not reading for me again. But your phone is not here. Yeah. But somebody should help us. Please, everybody read. Everybody read. Question what? I am.
Yes,
So before we don't stop and take it and do something, sit down. Yes, this one is not hard. This one is not hard. We'll do it together. My friend. So we're doing something. Make sure you're doing something before we do it together. Put effort and be doing something. People that started today are asking how many topics have you people learned. Remember, from January we are starting from the beginning. Okay. Okay. Move in a horizontal circle with one end. Calculate the tension force if the ball is moving at 1 centimeter per second. B, 6 meters per second. Right, let's try to do that.
I'll go into the reverse mode.
Once they tell you calculate tension force, without pointing to any direction, use the formula we just used. Once they tell you calculate tension force without of a circle, without pointing to any direction, like without telling you calculate tension force at the top, or at the bottom, or at the middle, use the formula we just used. That is vertical energy, horizontal is the centripetal force. Then use Pythagoras theorem to find the horizontal force, which is the tension. That's the answer. So you use the same formula we use, you get the same answer. And you get your answer. Sorry.
The past questions are available, you can get your own.
Yes, please, if you've not gotten physics past question, everything I'm teaching you, if you go to the part of circular motion in physics, everything I'm teaching, I took time to detail it there. You will see even more than what I'm saying now because we've not touched all the questions. As we progress, we'll touch all the questions. We'll cut across the board. If you get up and see a detailed review, even on conical pendulum that travels like a circle. My friend, we're full of fire. And see, very easy. So I have students that are very brilliant, who are very smart. Sharp. The investment is done, correct? If you used to disturb me with questions, now I'm giving you my own. Give me your phone and talk. Alright, so please, this one is simple. Is it not? Yes. Because it's just a repeat of what we just finished. So please, I want you to do this one now for me as your classwork and assignment. Because all I'm going to do here is simply, for this 120, I'll just say, first of all, I'll have mg, that is t on y-axis. Then I have t on x-axis, which is a better for mg squared over r. Is it not? Then the tension force now, the t itself, now the tf or tension force, just will be equal to square root of ty squared plus tx squared. That is what you are doing for the two. So you use it for this. So that if I want to get this will simply be the math is 2. Here I can use 10 for the gravity. So you use that for this. Why this one will simply be 2? Then the b is 120. Then square. The r is 1. 1 over 1 for A, so that if you finish it now, you see that you've gotten that the tension force is simply square root of the y of 20 plus 2 times 120. Sorry, first of all, 120 square is what? See, 120 square is what? Minus 2.
It's 8,800.
It is a 10,800 all square. So now, by the time you punch this for me, any lever, you will get the tension force for that 120 meters per second velocity. So punch everything here, what did you get?
8,800.
Okay, like this. 0.01. 0.01 like this. Are you sure? I know that that's will be written, right? So please, this one, I've done it. So you are doing the second one for me as your assignment. So please read out question. Any question there that has force. Now be sure. There's one that has circle. They are telling you calculate the force at top, bottom, middle. Is it? Number what?
That's number 6.
Number 6. Okay, the next one, I give it to me. Give me that number 6 question. The importance of all this thing is is that even when we now progress with gravitational force and all those people are moving force, you see that all the conical pendulum are there. You see that all the things we are doing here, we are cutting across even short topics that we are going to repeat. So number 6, you say A2 moves round. Example. Yes.
At point A,
Okay, then I have this solution. This side. This side is still shaping. Okay. Now, please, once you are giving this question, once you are giving this kind of question, we know that acceleration gravity due to gravity. If this is the ball, when this one is at point A, at point A, it will simply be having, notice something. At point A, this ball will be having anybody that is moving around the circle. First of all, has what we call centripetal acceleration. See now?
Yes.
And that centripetal acceleration gives us what we call, when we put empty centripetal force. Now, but when this ball is up here, as it's up here, it simply means that it moved up. See now? Because when it's down here, it simply means that it has moved down. Right? If you remember that our law, the body in an elevator, when the body in an elevator is moving up, you can catch it. That time with the body in an elevator, that in that case, it simply means that normal reaction will be greater than weight. You still remember? Yeah. Why when it's moving down, weight will be greater than normal reaction. You can take it. And that principle of dynamics, forward minus backward, equals NP. Hope you still remember that our principle. So now let's try to use the same principle here. You see that at this point, what I will have here is simply going to be my centripetal force, which is mv squared over r. Then when it's up, it simply means that gravity, we are going against gravity, minus weight, which is mg. That is going to be the tension force. So T is equals at this point. Why when it's at this point, point B, it will simply mean that it is going down. So I will have my centripetal force mv squared over r plus mg. Why when it's at this point, the tension here, sorry, T here will be equals the tension here will simply be the tension that is pulling it towards the center. So I will simply have at point C or point D, I will simply have mv squared over r. So at point C, let me do it here. So at point C, I'll simply have mv squared over r. Do you know that this is I'm saying this thing is equal to this, which means that this is equal to this? Is it not? This is equal to this, which means that this is equal to this. That means that at this point, the only thing I have is just centripetal force X. So this point, what I have is simply Fc minus the weight force, or the weight of that object. Right here, what I have at this point is Fc centripetal acceleration plus the weight of that force, or weight of that object, So if that body is at the top, it's not going to stay there, but we are considering that when it's at the top, at that top, it's going against gravity. Now, when it's at the down, that particular centripetal force that pulls it towards the center, and the weight of the object that is obeying gravity in that case, so it will be plus mg. Now, when it's at the center parts, that is point C and D, what we have at that point, at those points of convergence, is what we call our centripetal force. So that is the equation. So what we've done here is to simply graph the equation. So then you can ask us for point A. What I'll just be checking is, at this point, I have for point A, I have this, so I'll just write. Please, I'm rushing this so that we can quickly enter our banking of road. and frictional force is here. Once you are done with that, you can come to another force. You are going to switch to your one. So now, at point A, I'm going to be having mv squared over r minus m, which is going to be presented as saying my m is 2, David. Yes. Did they give me velocity? Let's check. Was velocity given to me? The ticket moves around the circle of the 2s. Apply the tension force at 0.8.3.3.2. I believe, when I wrote out this question, I believe we need to see velocity. But let's see if I find velocity. F equals to E is equals to W. They don't give us our R. They don't give us our W. That velocity is not there, actually. And there's no way we're finding velocity here. Is it not true? So it's not like what we're it's not like what they're asking us here is just to set up this. So that means that what our velocity is 2v squared over r minus 2 times 10 is what? 2 times 10, shall we? So that c is equal to this. So that I will have 1 over 1, shall we? So I have this here. So this is the same as
How will you divide it to
what do you make as my r? 2. Okay. So this is going to be the same as saying wait, I have talked about 2b squared minus 20, shall we? Then all over. Sorry. First of all, let's say. Calm down. I have 2 here, shall we? 2 into this, 1 minus 2, 2b squared. 2 here minus 2 times 2. Shall we straight now? So I have 2 times 20. And so I have 40. So it's simply going to be equals to 2b squared minus 40 over 2. So what it means is that if I'm finding this, instead of it simply going to be this is equals to 2b squared over 2 minus 40 over 2. And this is nothing that if this is equal to the tension. If I'm finding velocity, they will not ask me to find velocity. But as they ask me to find velocity here, I can say since this is equal to this and this is equal to this is the same as saying 2b squared. When I'm finding velocity, because this is my final answer for the tension. Then they don't give me the velocity. So I can say 2b squared over 2 minus 40 over 2. This is equal to this is equal to this. Everything here can be equal to 0. This one, hope you know, yes, everything here can be equal to 0. Are you aware? See now, the tension force is equal to this. This is the value of the tension force. Is it not true? So I'm saying, let's say they asked us in this question now to find the velocity. Let's say because they don't give us velocity now, but let's say they ask us to find velocity. Like I said, since this is equal to this, this is equal to this. This thing now becomes an equation. I can make this now, this value of t to be an equation. This is mathematics, it's mathematical. It's not wrong. So what I'll do is now, how do I put these things now to make this square? So that this now becomes 2b squared over 2 is equal to 40 over 2. And 40 over 2, even here, I can do 40 over 2 is 20. So this is going to be the same as saying, can I say this? We are no longer, we've gotten the tension force because what this thing means is that we are just setting up an expression for the tension force. But we are just progressing. Since they do not give us velocity, let's see if we can find the velocity. That's what we are doing. So that this now becomes 2b squared over 2 equals to 20. So I can say anything starting on this one is over 1. So 2 times this equals 1, f equals 1. So equals is 2b. But I divide both sides by 2, divide both sides by 2, you get that. So this will still divide this against 2. So it simply means that b squared is equal to 20. And taking the square root of both sides, we get that b square root cancel square. So b simply equals to square root of 20. 4 points. 4, 7. So V is equal to 4.4 seconds. Please, in a case where this one, notice that what they asked us to find is just tension. I will set this thing up so that our tension is simply the same as saying, our tension is just the same as saying V squared minus weight. C equals to V squared minus weight. That is what our tension is. But it's situation when they now go on and still tell you find the velocity. This is not how you find the velocity. Because if you cancel everything out here, this is what you're supposed to do. So why are we doing this? I'm trying to make sure that once he has to do with any topic we're doing, we cover everything. It's not up to you to use what we've got to go and read further. As you are reading, you will now say, okay, why you didn't get in that is because it's your first time. The first time to anything is not supposed to be very sweet. As you go, you start practicing and it will become qualities. The only people that will be following this thing very, very well are people that ate before coming. So if you did not eat before coming, what we are doing now is flying, because this is deep physics we are doing. This is no longer that surface physics that you come. You do this one that you already know, this one you already know, you are happy to do. What we are doing now is deep physics. Some of you, this is the first time you are meeting physics. This is circular dynamics. Alright, so please, the same way we got this, that's the same way you find for all the points. Now please, I want us to quickly rush to that question of frictional force and then banking of roads. Once we're done with the two questions, we can now do chemistry. Because chemistry is question. So please, read that question that has something to do with frictional force. Can I explain? What about this side? So this is just our tension. The tension is simply this square minus this square finish. That's the tension. This square minus this square. But then as we find the velocity, don't come and begin. See where some of people start doing it. They start doing this one. Come and mix this one. No. Once something is impossible, you're not doing all those things because this value. Alright. So read that question that has to do with starting friction and banking of roads. Let's do the two and then we are done for this.
A car makes a circular
A car makes a circular turn. I'm not bragging about it. Once you finish any topic, take your time, read on that topic. You see, I will cover everything on that topic and more. That's the truth. It's only if you're not paying attention to class. Once we finish any topic, go to your textbook that will be covered it and more. So you have to be serious with our work. The guy makes a regular talk of radius 30 meters, yes?
Between the tires and the road.
Between the tire
and the road is 0.5.
and the road is
0.5.
0.52.
What is the maximum speed?
Okay, what is the maximum ahead? You see, this question will be like this one just. What is the
Maximum speed at which the car
at which
the car can safely make two turns without light?
the safety plan without slide? Don't very in physics, you owe me a lot. I know what I'm saying. Once as you're coming from my class, getting my notes, paying attention, you owe me serious aid in physics. Alright, see. Whenever you're talking about road, notice that any question in physics, please pay attention. Any question in physics, where they start to tell you a car is turning. A car is turning. There are two things they can ask you in that question. One is you will see friction or they will tell you banking. What it means is that for a car to turn on a road or on a particular road, that there are two things that must happen. It's either there is friction, and if friction cannot help, They will now talk about banking, which is the next question that we're going to answer. And it's in this banking I will be telling you the technology or the engineering that is applied to make sure that when friction cannot help, that there's something that comes to play, which is that banking. Now, once you're talking about friction being what is helping when you are turning, it simply means that for a body to turn safely, friction on that road must be greater than or equal to the centripetal force. Hope you know that anybody that is turning, the first force that comes to play is the centripetal force. I ain't seen it. So if you notice, even most of the questions we solve, that means that we find tension force, centripetal force and the vertical. You see that when we finish, what you are having is not that much far from the centripetal force. I not seen it? Yes. So what it means is that anytime a body is turning, there are two forces that must determine that body turns safely, which is frictional force and centripetal force. And the centripetal force should be equal to or less than the frictional force. Then when we go to banking, we'll still talk about that. So in this kind of question, once you see a body is turning, well, how will it turn safely? Or what angle will do this one? Or what will happen to this one? Just be checking. Are they talking about friction here? If they're talking about friction, know that what they were talking about is banking. Two things. They will never put anything on it. Here, they will never tell you about creating friction. It must be static friction. So we say that static friction, Fs, must be equal to the centripetal force. So it now comes to the part where I tell you that it's important that anytime you are solving any question in physics, especially separal motion, you should be checking what force is causing the centripetal force. Or what force is helping the centripetal force. For example, the earth revolves around the sun. See that? Somebody can ask me what force is keeping the earth, or making the earth stay around the moon. The force there is simply force of gravity. Hope you know. So it's important. So when a body is turning through the road, the force here is static friction. And when a static friction is given by coefficient of static friction, we call it μs, then times the normal reaction. And this normal reaction is always equal to mg. Is it not true? Hope you know. mg equals to mg. Now remember this mg for mg, when a body is at an inclined plane, it is no longer mg but mg cos theta. You still remember, when I talk to inclined plane, I told you that normal reaction is equal to mg cos theta. We did the right things. We still do it again. So here is simply mg, so mu s. Now centripetal force is equal to what? mg squared over now. Should it? Yes. Alright. Now it is having m we cancel. Now again, I didn't have anything in common. Not to Chevy. So this is what it says mu s g equals to v squared over r. But notice that what they're asking us is maximum speed, right? So I can say, let this stand on this of course, multiply plus 1, so I have mu s. I just say mu so you don't get confused. Let me put this one. So g m is equal to v squared. Taking the square root of both sides, now this and this. This will cancel this. In fact, there's a way you start to do this physics. You see that physics is even sweeter than most of the courses you are doing. Should we notice it? What percent is free? Fine. So let's say you have v is equal to square root of
0.25, 0.55.
Okay, put that already.
Yes.
Very simple. So anytime, in fact, you can even write this way, you can even write modes. Anytime centripetal force of a body, or anytime a body is making a turn, that is the speed that is required by that car to make a safe turn. Anytime a body is turning, going through a curved path, that the speed, the maximum speed required by that car to make a safe turn is given by this. Coefficient of static friction times gravity times the radius. This is constant. This is the formula. Very constant. You never change. So I mean, not by knowing this thing of just it. So remember I also said because of objective that this I put import because I don't want to start doing less than or greater than I'm not doing inequality. But notice that an objective comes from box that you will say that the static friction must be greater than or equal to the centripetal force. Once the centripetal force becomes greater than the static friction, that car will have accident. It will turn and no return. Yes. So with that said, let's not put everything we have. Whenever the V will be equal to square root of coefficient of static friction, then 0.5. Then there's G, I can use 10. What makes 10? I am box for me. What do you have?
156. Square root of 1.
Square root of
156.
Square root of
56.
Okay, square root of 156. You are watching for me. What do you have?
12.49.
Okay, V is equals to 12.49 second. So now the next thing, which is the last one, the second question. That is the last question on binding is our last question for today. Remember I told you, anytime a body is curved, going through a curved path, two things to take note of. The two forces that will be there is what we call static friction and centripetal force. Static force, static friction is a static force, but we should talk about the friction. And again, it's now, when they are no longer telling you about static friction, what they will be telling you is binding. Binding now is the engineering that is done by raising the outer part of the road. Notice from today, you are going home. As you go home, you are observing any place that your bike normally touch. You notice that a part of that road is raised. Just be observing it today. If you study this way, you notice that the part of that road is raised. Observe it today, you notice it. So what that binding means is that it simply means raising the curved parts of, should I say, raising the outer edges of a curved road above the inner edges, so that your car can safely generate centripetal force. Safely generate centripetal force. So please write, binding means raising the outer edges of the curved road above the inner edges. Yes, binding of road. Binding of road, so that we can use it to answer the next question. Binding of road. Okay, we are surprised they are not putting money there. Binding of road. I said it means raising the outer edges of a curved road above the inner edges. Raising the curved part. You say raising the outer edges. I think it's better now. Raising the outer edges of a curved road above the inner edges to generate the necessary centripetal force. Raising the outer edges of a curved road above the inner edges to generate the necessary centripetal force. To generate the necessary centripetal force. Raising it, just as you are going now, be observing all those your road that you normally turn, you see that there's a part of it that is raised. So if your car even wants to slide, you now move it inside so that accident is not occur. So I said raising the outer edges of the curved road above the inner edges to provide or to generate the necessary centripetal force. I will say yes, this force. To generate the necessary centripetal force. Alright, so with that said, I want to clean this, can I?
No, please.
But see what you do. Let me take this question. You read the next question, the last question. So that you are using the correct form. So someone should read out the last question. Read the last question. That question that has to do with banking. We are not with everything in national.
A car makes a circular turn. A car makes a circular turn.
A car makes a
circular turn of radius.
Of radius.
50 meters
at 40 meters
at 40 meters per second.
At 40 meters per second.
At what angle?
At what angle?
The road will bank.
Ratio will be I won't let this back in now. So I won't put my money down.
So there's no friction.
So there's no friction. Well, this is the last question for today. So no friction is aware. Yes. You pay attention. I want you to understand. You owe me a We are not leaving anything. Everything must be covered. And by the time you check, you see that we've covered any question you need, you see that we've covered it. You are not using the initiative out of to solve it. You are using nothing. So let's start with this question. I want to clean the other side of the board.
Where you get to?
Alright. So anytime you hear banking, you don't need, you have no business with friction. Because the reason why banking is gone is because of the fact that friction will never be enough. You know that if let's say you have brain or maybe something, maybe people spray oil, like all this marketing on a particular part of the road, on a small part of the road. So all these things are things that provisions are made for. Things can happen. Lubricants can be touched, or the road can be touched by lubricants. And in that case, whatever you are thinking about starting provision will not work. So that's why they make provision for any top parts. So if we know that once a question is on banking, we have no business. So let's say this is my car. Let's say this is a car on a compass. The guy is looking at the compass. I don't want to start drawing all those things. So he's trying to then as he's trying to don't worry. We will not buy this car, but just understand. He's trying to turn. And as he's trying to turn, there's a part of it that will be raised. So that part of it that is raised, when you are judging it, let me clean this thing. You don't judge it the way they present it. You don't judge it by saying this now becomes the axis. This now becomes the axis where that road is raised. So now if you check it, next time your car is almost on an inclined plane, on an inclined path. As it's trying to come that path, so it comes. So I think this is too close. Let's make this one. So let's have it that this is my car. Let's use this. Please, this is my car. Let's say it has successfully come, but it's not in this direction. Yes, it has successfully come, but in this direction. Because I'm trying to imagine the come and still draw it facing you. I don't want to run mad. So let's say it has come. I cannot see the side that has come. Yes, so it's on top of this. Now we want to analyze the questions you will use so you don't grab. Our goal is to see that you never class in this class. So we say that anybody that is, let's say this car, when it's vertical like this, notice that this is the horizontal axis. And everything here is the vertical axis. And say that on the vertical axis we have N. N always acts on the vertical axis. And then on the, as N is acting, we have force to gravity, which is weight, M is acting downwards. So if we check it now, if we push this now, everything this side becomes our x-axis. So we can say this is the force of x-axis. And everything this way, everything this way becomes our, this side becomes our n. That is C now, but let me do it often. This side becomes my n, that is here, n. This side becomes my n. So I'm not confusing you. Now, if I know this, okay, this is NG. But please, for the fact that as narration due to gravity always acts straight, I want to call this the x-axis because this is also the x-axis. I want to call this also the x-axis. So I don't confuse with that for the axis. So let me be the force. This is the force of x-axis. We have put it. Yes. So my NG on this, when it comes, it's not supposed to go this way. I think that's important. It's not supposed to go this way. Rather, it should be straight. Remember, force due to gravity. How we define it? Always acting The center. So if I have this, that means that my mg should be somewhere here. Down. Mg. That means here. Mg. Okay. That means that my end actually is supposed to be going this way, vertically. Down. Vertically. That is this ending now. That is first on y-axis. First on y-axis. Here we need about vertical y-axis. So let's say this is my Fy. So that is I need about mg. So let me write it here. Now notice that if this is my x-axis, without this one, I'm trying to make an angle. Notice that everything here is either my x-axis. That is my fx. Now, this angle obtained here is theta. It is from here we derive the equations. So because it is at an angle, that thing that is happening is acting at an angle. We'll now say, looking at this now, theta will be equal to this side because opposite. This side basically theta is opposition. Now why did I put theta here? Because this is the angle made from the part that this car formed and that part of banking. The part that makes that angle, that is what I'm taking. I'm not going to put it. So theta now becomes equals to theta, I will say sin theta, because it's opposite of hypotenuse. I will say sin theta should be equal to fx. Is it not true? All over hypotenuse, which is what? Mg. Y cos theta to be equal to what? The adjacent. So adjacent, which is what? Fy. All over what? Mg. So what this means is that anytime you have an inclined plane, and I don't want you to be doing this thing, we've done it before. I don't want you to be doing this thing. Anytime you have an inclined plane, so that you don't stress yourself inside the exam hall. Just come and say somewhere that force on the x-axis will be equal to mg sin theta. While force on the y-axis will be equal to mg cos theta. And how you remember it is that you need to know that naturally cos theta is always for x, but when it's inclined plane, cos theta goes to the y sine goes to the x. Now if you know this now, what you now say to yourself again is this. On the y-axis, anything that is circular motion, on the y-axis, notice that on the y-axis, this is y, and on the y-axis, what I have is mg. This Fy is mg. That is normal reaction. While on the x-axis, when I told you before this example, I told you that on the x-axis of the circular part, the force found there is centripetal force. Hope you still remember this centripetal force. So for here, what I will have is simply mv squared over r. If you like, cram it. If you like, don't cram it. But on the x-axis of the circular part, of the circular motion, the only force found there is always the centripetal force. So what I have now is essentially saying mv squared. So everything here is for this one. While everything here is for this one. And it's equal to, so mv squared over r is equal to mg sin theta. Now, then this side I have mg is equal to mg cos theta. What I will say is m can cancel m here. Is it not true? M can also cancel m here. Now notice that I'm not left with putting these two side to side. Putting these two side to side. That is the x-axis and the y-axis. Notice that sin theta over cos theta always give me tan. Is it not true? Yes. Please remember when I taught you dynamics, I told you that x always comes before the y. That's why I'm intentionally doing the x before the y. So see, if I'm putting these two things together, I will see that I'm having g here. Is it not true? I'm having g here and I'm having g as well. So g can cancel g. Is it not true? So I'm left with b square over r. Let's be sure. Yes? Yes, I'm having now g square over r. Is equal to g. See, this is g then sin theta. So the only thing remaining here is just the cos theta for down here for the y-axis. Just the cos theta. Is it not true? So now that cos theta, so it's more like saying divide this by this. So by the time I divide everything on this x with this, the next step over cos theta that is remaining, this gives me that. This thing gives me that. It's not hard. So what I did is actually, I get my x-axis, get my y-axis, I divide my x-axis, force on the x-axis, everything by the ones on the y-axis. By the time I finish, I'm left with this. So that the next thing, let me give this question. What's the question? I'm coming. So the next thing that I'm left with B squared over R is equal to G times theta. Hope you agree? Yes. But remember that the question asked me, at what point should this road be back? At what angle should the road be back? You know what they asked me? So please, the principle I use is find the x, find the y first, then divide. Then that is what I've done here. Now, after it, I now said that if you're asking me, what is the maximum speed when the road is back? The maximum speed when the road is back is simply going to be, if this arrow transfer, you now have b squared equals to g r times theta. Then, taking the square root of both sides, you just have this v. Anytime you hear the road is back, the maximum speed that a banked road can make use of in order to generate centripetal force safely is simply equals to square root of g r times theta. But in this question, they did not ask me to find maximum speed. Rather, what they're asking me is the angle, which is theta. So in this case, instead of doing this, I will simply try to make theta something like that. But notice that whenever a road is banned and they ask me what is the maximum speed, this is what you're pointing your to. This is the formula to use. It is different from when friction. When you have friction and you're generating centripetal force safely, when a road is banned, I told you two things. So if that be the case, making theta solid of the formula, I will have divide both sides by g. Divide both sides by g. And notice that this is b squared over r divided by g over 1. This is the sentence saying times 1 over g. Here. Check. Hope you know what this is. Which means that this is going to be sentence saying b squared over rg. So I'll just pull it out. So that means that this is sentence saying b squared over rg. This will cancel this equals to so making it a sort of formula simply means tan crossing the quantity equals what? Tan inverse. So now theta equals tan inverse. Equals to tan inverse of b squared over rg. So anytime they ask you at what angle should the road be back, this is constant. It's going to be tan inverse of b squared over rg. How we derive it is very constant. It is simply using the principles of inclined plane. And notice that every of these formulas we derive, we always make use of it. Notice that now that we are doing something that is like inclined plane, we do not generate something different. It will always be the same. So once you know one thing in physics, it is always going to be the same. There will be so many ways to do it, which proves it are correct. But each one you know will always be the same. So inclined plane will always have Fy to be mg cos theta, Fx to be mg sin theta. So putting it side to side, you now see that you are left with tan theta plus sin theta over cos theta. So when you do it, make it consider the formula you have. So from that question we are given, what we are going to simply have is that theta will be equal to tan inverse of what the rating has by you?
40 meters per second.
40?
Yes.
Okay, 40 square. And all over. Our R is what?
Then arrow is sorry.
50. Then our G, can you spell on 9.8?
10.
10. By the time you punch this and make it tan inverse, you get your answer.
72.64.
72.64. Shall we? You take it to tan inverse?
Yes.
Okay. And it's going to be in the green. 0.64 degrees. See? It is in tutorials. You are impregnated academically. It is in class you are impregnated with knowledge. Let me tell you the truth. If today is your first time, everything we draw here might look as if it's hard. It is not hard. Just watch the video. Take your time. Go through the note what given before now. Now when you do it over and over, so watching the video, it will be very easy. But have it in mind that everything that we do so far and that we do in tutorial, we make sure that we cover excellent Reason being that you don't have to go inside the exam hall and be looking for answers or feel like this one is new to you. Because that's the case of most students. You will solve a lot of questions, but you don't know the simple questions you are solving. When the exam comes, you are looking empty. You are not asking yourself, I thought I did this one, did this one. So that is the essence of this class. So when you go home, revisit everything we've done so far. I think the only thing I'm owing you, which we will do tomorrow, is how to generate moment of inertia of a spec. Can you hear me? Yes, for a spec, how to generate moment of inertia. But you can even do it on your own when you get home, using the same principles we've given you. But just like for a spec, because of the fact that it's not a full circle, it will no longer be from zero. The integral will no longer be from 0 to r, but rather from minus r to r. I ask. What's the relationship between center of gravity and friction? Okay. See, the relationship between, we ask, what's the relationship between centripetal force, center of gravity, and friction? Well, let me start with friction. Naturally, you know that when they are calling friction, what they are indirectly calling it is that thing you normally call centrifugal force. For anybody that is moving like in a circular path, the frictional force there is centrifugal. For example, if I'm rotating something like this, a part of me in time will get tired. Are you not seeing it? Yes. Reason being that there will be resistance. That particular thing I'm turning is giving me resistance. And that resistance, my hand will feel it. At a point, I want to stop. Now, the friction here, when they call it friction, some books might call it force, centrifugal force. They're talking about the same thing. Now, the relationship between all these things is that for a body to even go through what we call a circular motion, there must be centripetal force. And there will be centripetal acceleration. Because in circular motion, we are no longer dealing with acceleration being changed in direction. Rather, acceleration in circular motion is simply pointing movement of velocity. And as the body moves, the movement or the motion of that body towards the center. That is what acceleration is doing here. As it's moving, how is it being pointed to the center? Because the minute it starts being pointed to the center, it will no longer maintain that central part. So the work of acceleration in circular motion is no longer just to look at change of velocity, but rather pointing velocity towards the center of that part. Now for gravity, the relationship it and gravity is simply that once a body is rotating, as that body is rotating, there will be a force acting on it each time it goes up and each time it comes down. So that force that will be acting on it, that is checking when it's going up, the pull on it, everybody, anything that is happening on earth, there will always be a pull on it towards the center. So that pull, natural pull of everybody downwards is what we call the center of gravity. So putting it together is simply, without centripetal force, there will be no circular motion. I see it. And without gravity, first of all, there will be nothing like, you will not even have anything at all, not to talk of circular motion. So gravity, force of gravity will always be there, trying to make it that if it's going up, it must come down. So the relationship is, it points everything that goes up in the circular part downwards. While centripetal acceleration points everything that is going in circular motion towards the center. So gravity downwards, centripetal force towards the center. While friction is simply pointing that body away from the center. Yes. So it's trying to pull it out of the center. So I think with what we know so far with our okay. So please, I want to believe that with these 2 points of man, I'll be able to convince you and not confuse you that it is serious. You get impregnated academically. It is in class you are presented with knowledge. Yes. Jesus said, "Follow your many fishers of men," right? Is it not true? Is it glorious to follow us and make you fishers of A's? Yes. You get impregnated and you deliver. It's So please, with this request of mine, let's stop here. So that we do another course. Let's do another course. We try for today. So tomorrow. Excuse me. Yes. So please, in the school now, in the school, the one why are they clapping? Yes. So please, let's do another course.